So yeah, my name is Jennifer Carlston. I'm a software architect at Pluralsight. When I started there, I wanted to understand this question. I came into the system blind. I didn't know what it looked like when I started, and wanted to answer like questions around what kind of eventing patterns are we using? What kind of events do we have? What's in the events? With my team, I've completed a lot of different rounds of discovery. I looked at code from something like, I don't know, 100 different bounded contexts. Generally tried to synthesize what I've learned and have a few axioms that I might share with you today, maybe some patterns, some technologies that we're using. So as of right now, we just finished a round of discovery with the teams where we interviewed a bunch of different people, took all of that information, all the transcripts, and are synthesizing it right now. So that's what I was doing literally just before this talk. As I was going through this, I asked people how things were set up. I wanted to learn some history and have been reflecting where we're at today. This is a really simplified view of what our system looked like just before I was hired. At that time, there were maybe 20 different engineering teams and 40 different bounded contexts. It's changed a lot since that first day. At that time, we had an ephemeral eventing system using Rabbit that shared state changes in a fan-out exchange from one bounded context to another. And we had self-healing API that backed the state and data transfer of information from the exchange up. So if an event was missed, teams would hit the self-heal endpoint and build current state. The system was robust and eventually consistent, but historical state was often lost. It worked really well for engineering teams, but it was difficult for teams like analytics to understand the history without additional features and load being put onto this synchronous self-healing APIs. Many teams used EventSourcing internal to their BC, but they didn't publish all the events through this system. So as we were growing, things were getting more complex, lots of different variables, and analysts wanted more data for their models. So that's what got me wondering how teams and people were using the events, what was in them. But in order to know what's in an event, I wanted to be sure I'm clear on what I mean when I say event. And no, I do not mean this kind of equestrian event. One of my team members was actually an accomplished equestrian, and I wanted to define event for the space I worked in. It's also, I don't mean this kind of event. As far as space horror movies go, this one is pretty eventful. But no, I don't mean that. And neither by event do I mean this. This is kind of a mix of the two previous. It's a bit like these two combined. So what I learned, first off, events are foundational units of change in a system. Teams approach problems very differently across their contexts, and they generally didn't share the events they used to derive state unless someone needed them. It's got me wanting to look under the hood, and there's now something like 50 teams and over 100 different BCs. I found a few things to be true as my team and I researched the system. One is that events reflect change at a certain point of time. And I think that's a pretty accepted bit of truth across many of the systems that I've worked in. Events, because of this, because they're units of change, they're past tense, atomic, immutable, and orderly. Events in our system broadcast what happened, and others worked out what they needed to do next. The system in place was choreographed rather than orchestrated. Ordering events between different systems of publication can be difficult. And people on the teams that I talked to at the time spoke to me about problems they had figuring out order. Teams might publish a Rabbit message, but there could be a delay on the publication to the Kafka event bus that was added shortly after I started. They wanted to know how to solve this problem. Ordering can be a hard problem to solve, especially when you're working across different methods and technologies of delivery. One thing that we put in place were message acknowledgements. Teams started consuming their own streams and publishing notification events after they act delivery. This can be somewhat slow and cumbersome, but it guaranteed delivery notification in an orderly way. Teams sometimes didn't capture the entire life cycle of events in their BC. And something that I found to be very true is that events do express life cycles. This might be for a number of reasons, but systems that have evolving versions and evolutions of events handle change better over time. Yeah, the ordering is definitely a repeating topic across many talks today and yesterday. There's a lot of devil in those details. So yeah, I knew from my previous jobs in finance that knowing the full life cycle, not only of current events around event, but around event evolution, can help you crosswalk between versions. Building a system that can add attributes, associate new relations, modify and link schemas can be a powerful model for change over time. We put Avro in place, but there's still schema evolution patterns that it can't handle as gracefully as we'd like. So as the context changed, the events and naming conventions made less sense. So events exist within a context or a domain. Sometimes domains combine and change. There were associations being made with organizational structures that no longer existed. Company structure was reflected in the infrastructure, code, events, and domains. It's really important to be mindful of this as you go through a reorganization. I've been through a few reorgs in my career, and there are always loose ends that are difficult to clean up in code and in the infrastructure. And it's important to be mindful of this when you're building an eventing structure. Something we added to our events was an enveloping schema that had correlation keys. I'll talk about this a little later on, but the format of the enveloping schema can help with sense making in your system, or it can get in the way of it. The schemas create constraints, and different categorizations create different trade-offs. So some schemas in our system are very difficult to evolve because the model was not built to change over time. Another reason things might make a schema difficult to evolve are the number of consumers and dependencies that grow around the system. Schemas create a need for backward compatibility and handling breaking changes, capturing schema evolutions, and providing those crosswalks between schemas as an entity or aggregate topic evolves is possible. Capturing the life cycle of change is something you can design for in better or worse ways. And that's really something I want to hit home today, this current time. Another thing to be mindful of is that they reflect events are the sentences that define the actions and abilities of your systems. They express automated objectives. Your objectives might change over time, and that also has implications for your system. They reflect and define the structure of a domain, its syntax, and what you're doing inside of it. As your objectives and problems change, so do the possible events, which can cause event and entity schemas to change. There's an evolution of potential states. The number of things in the set can change, as well as the value of each item within the set. So another thing I've learned is that the categories speak to the abstractions in our system. They help define the ubiquitous and controlled vocabulary, your taxonomy, as well as your domain vocabulary, which I consider a vernacular. When I started, we used terms like contracts, content, libraries, but those weren't actually represented in the eventing system. And we've added them over time, and the addition of those entities changed how our system expresses itself. So events have type-specific attributes. This is an example of a cloud event from the CNCF spec. Notice the type-specific key value pairs. Events are related within the system of record. So you have relational associations inside of your events oftentimes. That's what we've seen in our system. They can contain relations. This example says domain is the orders. So there's an order form and there's a logger that's logging an order to a database. And there's a correlation ID in there to be able to track across the different systems what's going on and where it originated. There's also an order ID that relates it to a specific event in another area of the system. So state transfer streams come into play a lot in our system. When I say topic, that's often what I'm talking about. Kafka topics, or really what a topic is a phrase, a nominal phrase that describes something about your system or something about an entity. Some kind of noun of some kind. The bounded context owns a number of business-specific entities. They own a number of topics, they own events, and they own commands that are expressed in the code. The team defines a schema and a set of events that they message out about. They maintain the code that emits the events and manage the publication of events and state to their topics. So in this example, identity owns the user topic. They define a schema and a set of events around authentication and information that helps users log into a site. They message out about the users being logged in or being removed from the system. Say, like if there's a GDPR request, they let people know that their information should be removed and anonymized. So the profile team owns details about a user. They aggregate events from around the system. They determine all of the various things a user has done on the site based on other messages from other teams. The plan team manages what users are part of what teams. They all need to share information in order to work, but they all need to act and move independently of each other. The current state of a user might be important for identity and plans, but historical state might be important for profile. So events can contain state or be stateless. It's helpful to know when. How you're handling state. How are you handling state in an event source system? What drives state? Who derives the state and who transfers the state? Who's figuring out what the projections are. When I started, all of our events were ephemeral that were messaged out by the teams. The company then added a system that retained a historical record of state changes. Aggregates of domain events combined into entity streams. The entity streams reflect the current and historical state of an entity or combination of entities into a domain aggregate. Bounded contexts might own a number of different business-specific entities, a single one, and manage entities and relationships between other entities they don't own. So events can be logged or they're ephemeral. I've touched on this a little bit, but it's really helpful to know when and why. They might be stateless notifications with pointers to relations. Logged events might contain all or part of a domain entity's state. It's actually really important for events to reflect both domain and ubiquitous language to help humans make more sense of the systems over time. That's an important distinction to make when you're building out your naming conventions and your standards. Events are generated to let the business know that some event has been made, some event has been met. There was a need that was filled, even if it's a business need rather than a user one. Events are aggregated and grouped based on objective. We wanted to surface what a user had done throughout the system in an aggregate in one of our VCs. They consumed messages and topics from around the system and built a new combination of data and published that out. Events are often equated with the messages that reflect them. The event is not the message, but they're a source of truth for what happened in a system. This can be an important and fundamental distinction to make and to understand when dealing with CAP theorem. Knowing that there might be consistency or latency issues with events can help you track down problems, and having service level agreements on the systems that transfer events can help you improve your quality. One of my team members put it well: event messages are the fumes left from an operation that ran within a system. An entity is a noun or an object in the business domain and is often part of the taxonomy. A topic is a noun phrase, a nominal phrase, like I mentioned. earlier that can be used as a noun and might be derived from multiple entities or domain objects. An aggregate root is the entry point to traverse and initialize other entities in a domain. So an event is not an entity or an aggregate, but they might reflect that. A topic they're not a topic or an aggregate, but they might be included within. And they're not a command or an operation. They might reflect the completion of a command or an operation. Hopefully I'm not going too fast. Probably am. So I'll just call this out with that specific example that I gave before. Events notify people of changes that have been made. They may also include the changes, but they don't have to unless you're using them to derive state, say, in an event source system. They aren't entities, they aren't aggregates, and they aren't commands. So like in this example, the event is the user signed in or the user added. The command is sign in. The topics might be the user, which is the root. Might have user integrations and user sign-ins, and those events might be reflected in both of those topics. So moving on to what an event must actually contain, kind of the meat of this talk. So I would say there must be at least one reference to either an aggregate, an entity, or a domain, or all three. That's possible. That's something that an event must have in it in some form. You want it to have at least one element or period of time. So time is a really important aspect of an event. If you don't have a timestamp, you don't have an event. You should have at least one past tense verb to reflect what happened, the objective that you were trying to complete, and what's in an event. So here's some examples of things that we've included in events in our system. You might have the name, that would be the domain, or maybe some kind of larger system saga, possibly. Depends, iffy on that one. You might have an aggregate that isn't quite a domain object and isn't quite a value object, or it might be a combination of those things. You might have a type that would maybe specify a schema ID. If you're trying to do evolutionary schemas over time, you might version those schemas, or you might have some kind of translation or crosswalk between them. Metadata, you might have, that's where you might include your timestamp. You might have your publisher, your correlation key, your version, any other labels, and then you have your body and the properties that are within that specific structure. So inside of an event body, you might have a primary key, composite foreign keys, so like your relations. You might have command input parameters. If that's applicable, you could include what you use to change the event. So maybe a little bit of state, or you could have a full set of state within that event. Depending on how you're designing your system and depending on what information needs to be shared out with the consuming teams. Temporal coupling and causal relationships might require additional information to be included. That's, again, where you get into statefulness or statelessness and how much state you're actually included in your event. There are lots of different variations within that. And it's important to talk through with the publishers, with how you're modeling your data, with business analysts to figure out what's really important for the business to know coming outside of a BC. So there are some general types of events that I've at least noticed in my experience. There are behavioral ones, telemetric, domain, which include both state state change and structural evolution. And then something we've been exploring lately are system level events that might be at a higher level than what we've currently got defined in our system. So behavioral might be stored separately, or it may not be made public, depending on the business need. May help build entity state, but it's not necessarily included as state property is in an entity or in the entity events. Some examples of a behavioral event might be user sign-in attempted, user assessment completed, offer code redeem button clicked by user. So they're lower level events than you might want to make public. There's telemetric events. They're generally stored either inside contextual logs or internal systems. They contain information around internal dependencies, changes, applications, errors, and considered telemetric events. They're notifications internal to a system, and they're not relevant outside of it. And then state change events. These are the meat of the ones that we're talking about. They're a set of essential changes that define the business model. They're the life cycle events. They're associated as part of the changes to historical or current state of a domain entity. They're used for choreography. They're used to build state in an event source system, and they're consistently timestamped and idempotent. They are also related to the structure evolution events, which could be something like how you evolve state or how you change what possible state events are within the system that you've built. So let's say you've got a domain that you're building events for. That's great. You've got a life cycle defined. Now the life cycle changes. Some new events are added to the life cycle. Or maybe you didn't capture all of them when you built it out first, and you need to add some. These are the structural evolution events that you would add more steps in your life cycle to. So as we're going through and trying to figure out what's in an event, what principles can help us do that? For those in the back, Little's Law is really important. Understanding flow, understanding the flow units and process and the cycle time and your throughput can help you define a better eventing system and a better event source system. Throughput time increases when there's an increase in flow units or unhandled variability. How you handle the number of flow units and find innovative ways to deal with variability and queues is like essential to what we're building. You can use DAGs, you can correlate attributes, you can abstract types. The point is, run through your eventing system on paper, measure it twice, cut once, really understand what's happening and how you're deriving state and what parts of state are stored within and outside of your eventing and event sourcing system. So big part of building out your data model, start by identifying the key events that contribute to solving the problem statement. Don't build the data model first. Just start thinking about the events and map the flow of them out. CRUD are not the events that you're really interested in. You want to go a level higher than those CRUD events. So I need to verify my identity because I want to access a feature in order to complete a task. Pretty basic scenario. These are what the events might look like. I need to user login attempted. Oh, I failed. Oh, I attempted again. I succeeded because I accessed a course. I completed the course, and that allowed me to complete a certification. All of those are high enough level domain events that you would define to help you understand what's happening for a user within your system. When you're building out the events in the event sourcing system, I've found that BDD is your friend. Having analysts, having people who understand what the customers want and what they need, and general scenarios around how they're going to be using the system is really helpful for figuring out the events and the naming of those events. So you want to make sure you have the full life cycle of the domain and that it can be expressed in events. A lot of times people forget events that, and they're not recording them in the system, and it actually ends up limiting them and their growth later. So events must contain the total life cycle of a domain as you understand it. They often forget to think about evolutionary, compaction, and death cycles with regards to events. For a system to stay healthy, you have to have birth, change, compaction, which is state transfer, evolution, and death. They're all important. And something that I've noticed in the systems I've seen is not everybody includes all of those types of events in their systems. CRUD's only part of the story, and it's not part of the ubiquitous language. It's barely part of the domain language. Look for things that are better descriptors when you're building out your events, and build eventing systems that express complete evolutionary cycles. Thinking about the cycles of event flow can help you build more flexible systems. It will help you define clear language, objectives, aggregates, and entities. So life cycles, it might look like something, this is kind of like a graphic to help you think about it. There's a start, there's a number of events and an end, and there might be, and that would be the aggregate root. But within that, there might be a number of different events that are built up into a larger level event. Any number of ways you could organize that, but it's good to think about the hierarchy. The context defines the view or the level of abstraction for boundaries, activities, and flow units. So the context changes based on where you're looking. Your focus is what matters. Build a system where events and entities can evolve with the business. Yeah, I'm think about that. Think about what it needs to evolve, not just to change state. Attributes have life cycles as well. They're often part of the default config of a life cycle. Attributes can be built, assigned, and retired using evolutionary events in a system designed to handle them. Attributive events are part of an evolutionary event design. And naming things well. What's in a name? That which we call a rose by any other name would smell as sweet. Really, what Juliet was trying to say, a name is a label that acts to distinguish one thing from another. It does not create value or true meaning. Meaning is assigned, attributes are assigned, value is assigned. That's how you build a domain. That's how you build a field of knowledge. That's how we build our ubiquitous language. Naming things, when you name things, use standards and principles, document those naming conventions, and assign and relate events and entities carefully. You can build an eventing system up from zero if you design the life cycle correctly, where you can evolve and change the events and the schemas over time, from one single identity and a timestamp to adding attributes, to adding schemas, to eventing at higher levels with entities and aggregates. So naming things. This is just something cool that I thought I'd include. A hypernym is a general category of a thing, a bird, let's say. Hyponym would be a robin. That would be like maybe a more specific instance. Co-hyponyms describe or are some kind of differentiating set of terms or phrases. So a robin is a migratory bird with a clear melodious song, a reddish breast, and a gray or black upper plumage. So a hypernym might define a domain. A hyponym would define the entity. Co-hyponyms might help you define a schema for the entity. Bird is the domain, robin is the entity. Migration, song, coloring might be included in the schema. You might relate it to a TV play at another domain through a relational association using a compound polytheme. So that's not fully related to a bird, but it does have some kind of relation to it. Hopefully I said that right. Let's see. So formatting things. Schema registries that have crosswalks can help you build a well-understood taxonomy. That can help everyone understand your system and find information more quickly. There's some cool technology that we're starting to experiment with in this area. I can talk about that in the discussion if you'd like. Formatting things. So schema registries improve discoverability, correlation, and tracing and ontology. So use schema registries if you can. I can't speak. They make life so much easier because you can evolve the system independently from the names. It allows you to decouple. When I was talking about like organizational change, if you just give things IDs and then overlay an organizational structure on top of it, you can then not be tied into the structure of your company changing to your eventing and your domain logic. So require clear problem statements and objectives from your product organizations. I cannot, like if they don't give it to you, you build those clear problem statements with your teams and confirm them with the product reps. Make sure that you know what problem you're solving before you actually start formatting things. And then standardize and document your organizing principles. Having something that helps you understand why you created your data model and what you want to do with it is really helpful later on down the line when you may want to change it or you may want to evolve it or any number of things. When, let's say, you get hit by a bus, you've got your team who can go back to that documentation and understand what's going on there. And then clearly define the relationships, really get down to what team owns what entities, what team owns what events, and how you're going to be organizing them. And then also the state transfers, as well as how you're defining ownership. Ownership can be a whole separate thing, like data governance and ownership is a whole thing that a lot of organizations have some I think this is an area of the field that will evolve as we get better at this. But I've seen a lot of kind of, antiquated thinking laying on top of data governance and limiting our ability to evolve an eventing system. So one quote we had from one of these discovery things was teams process topic streams for current and historical entity state. I think that's important for understanding how you format things and how you're going to evolve them. Let's see. So here's some examples from the real world. This is what I started with. I talked about this at the beginning. We had state transferred through the Shappies. Events were ephemeral, and data stores didn't store a history of changes over time. This is what it looked like about the week I started. We added on a custom Kafka pub sub wrapper with a Kafka cluster behind it. Teams are starting to load publishing events into a Kafka event log, create topics and messages using this API wrapper. Teams could subscribe and materialize data into their databases from other teams inside of read-only tables in Postgres with another API. So that was what we built out, and it was before there were a whole lot of managed solutions with Kafka or Confluent or things like that. As the system's grown, our team's understanding of these systems has changed. How we do, like how we create entities, how we create these topics, what's going in these topics, it's all changing all the time, and we're getting better at it. And that's where some of this language is coming from for me. And I'd love to have more discussions with other people, and I'm very much enjoying this conference with hearing what other people are doing. So we've added a lot of different features to share and process current and historical state between teams. We now have a data lake that our analysts are able to use to do less than real-time data modeling and discovery. So let's see. We started requiring, I talked about this a little, we started requiring acknowledgments on any messages published to our Rabbit exchange. This helped us find a bug in one of our platform tools that had been causing inconsistent publishing issues and caused more Chappy traffic than was necessary when we added those acts. Teams started loading events and entities into Kafka, and for a while it was a bit like the Wild West with all of these Kafka topics that were maybe like, I don't know, they're putting all sorts of data and there wasn't type consistency on some of it and maybe not enough type checks on the custom wrapper. It's gotten better over time, but there's still a lot of work that we're figuring out. We also started experimenting with GraphQL endpoints between domains to help bolster the Shoppies or just give teams kind of a different view on the data. And at a certain point, I started a working group. We created an RFC in our company and made recommendations on how to start correlating data across multiple systems. The working group ran some experiments and made a recommendation to add a correlation key to all web request traffic and pass that ID through the system to help our support org track issues between user experiences, between domain data stores, between API requests, Rabbit messages, and the Kafka entity state changes as well. So, and those correlation keys go into the analytics tools, and we're able to group up sets of information that aren't related in the system in other ways. And it ends up in the data lake, and yeah, a number of different service groups use it. We've added a lot of different technology to handle different use cases across a wide variety of platforms, teams, and domains. We have teams programming in lots of different languages, using lots of different technologies, using different services. No one team has all of these solutions implemented. There are teams that use Debezium to share data between Postgres, the Postgres wall log, and Kafka using a native publisher. There are teams that use Lambdas to publish data through native Kafka or to make API calls. Teams are beginning to experiment with temporary analytic data sets pulled from our data lake via Fivetran and Snowflake. Data scientists are using Airflow to trigger workflows based on different sensors and operators they've created to handle events that are more important for their models. We've just acquired another company that's completely serverless and cloud native. They use tools like SQS and SNS in a similar pattern to ours from a few years back. And we're all learning more about their eventing patterns, what's in their events, and what's important for all of us as we march into the future. As our team interviewed the engineers, we came across mentions of a lot of different technology and different eventing patterns. A cool one that I thought was really neat was we've got a team that builds hands-on labs, and they have their own Kubernetes cluster, and that Kubernetes cluster uses event sourcing with Kubernetes operators and an etcd maintaining state between the nodes on the pods that they spin up. Data scientists are managing workflow sensors and operators with Airflow. I mentioned that already. There's a lot of information going back and forth between all of these different teams, and you can see how many different kinds of tech we have because we've got people running experiments and trying to learn new technology all the time. I see a question there around adding correlation IDs retrospectively is quite a hard task. So what we did is we came up, I pulled a working group together of people who were interested from around the business, engineers and teams who thought that this could be powerful. We all got together, talked about it, and it took a few months to really come up with a plan on how we were going to do it. We had 3 teams run different experiments around how to implement the correlation keys. And what came back was that we would be putting it in different parts of different message headers, essentially. So Kafka has message headers that we were putting them in. We put them into Rabbit message headers, and we put them into the request message headers. All of those were something we said that teams will, in order to get into production, they would have to implement those headers in their code. So we didn't require it for code that wasn't changing, but any code that was changing, it became part of our implementation checklist. And so as teams have added features to their systems, which like they're deploying daily a lot of times, that was part of the implementation checklist that they had to go through in order to get to prod. So that's how we handled that. And I believe there are still a few BCs that haven't implemented it, but most of them have at this point. And so hopefully this explains a little bit more about what's in an event. The whole thing is really, it depends on your objective and on your business.